Hello and welcome to the Biopsych Advanced Search webinar. In this webinar, we're going to give you a quick introduction to our Structured Advanced Query page and the searches you can do with that page. This search tool is intended for more advanced users who need a little bit more than our basic and intermediate searches can provide, and who are willing to understand a little bit more about how the databases are actually put together. As a refresher, just remember that the quick search is always up here on the right, and the other searches are all accessible from the search menu here. So for example, I can go to the search menu, see the range of intermediate searches, and go here and click on Advanced to get to the Structured Advanced Query page. I'll do that now. This is the Structured Advanced Query page. This gives you a structured format to use our BioVelo Advanced Query language to query the database. Now this doesn't require that you understand the underlying BioVelo language, although there is an option to use that too, but it does again require that you be willing to invest a little time in understanding how Biopsych databases are structured. Before we get into how one actually puts a search in here, I'll point out a couple things about the top of the page. We have this button here that switches to the Freeform Advanced Query page. I'll click that now. And here we have the Freeform Advanced Query page where you can put in queries directly in the BioVelo query language. Now you're going to need to invest some time to learn BioVelo if you want to, but fortunately we have tools that will actually help you look at how your structured queries translate into BioVelo queries. But we're not actually going to discuss that in this webinar. We're going to focus on the Structured Advanced Query page. So I'll head back now. The next thing on the Structured Advanced Query page is a link to the query documentation. Let's pull that up. The documentation extensively describes how the Structured Advanced Query page works and goes on to describe how to use the BioVelo language on the Freeform Advanced Query page. Just remember, this is there. After this webinar, hopefully you'll be able to just start playing with the Structured Advanced Query page, but if you need more assistance, just remember the documentation is always just one click away. As I've mentioned already, you'll need to invest a little time sometimes in understanding how our Biopsych databases are put together to be able to successfully ask the questions you want in the Structured Advanced Query page. You may understand the underlying biology, but you may need to read a little bit to understand, for example, that we don't connect enzymes directly to reactions in terms of database objects, but have a thing in between called an enzymatic reaction, and there's a very good reason for doing that. And we touch on it a little bit in some of the other webinars, but it's just that kind of thing. And you'll discover most of them actually just by inspection as you go through and use the Structured Advanced Query. But if you'd like to do a little background reading first, remember that we always have this link on the left search bar to our Pathway Tools software page. And this goes to a Pathway Tools information page that has lots of just little interesting links and discussions about the Pathway Tools software, including things like the Pathway Tools schema. That is to say, how do we actually structure things in the database? I'll just give you a glance of the schema right now. For example, this takes a look at how a gene can go on to a bifunctional monomer that carries out two reactions that may both be involved in a pathway. And as I mentioned, we have this example of a gene object or frame in our database being linked to the monomer frame, which is linked to the constituent enzymatic reaction frames that then link it to the reaction frames. And so if you do a query that's going to try to walk its way through here, you're going to need to know that there is a here. There is an enzymatic reaction in between the reaction and the monomer. And once again, you'll find most of these things by inspection when you're actually playing with the Structured Advanced Query page. And if you're the kind of person who's going to use the Structured Advanced Query, you're probably going to be comfortable with finding these things out, and you'll actually be able to start figuring them out just by looking at the drop-down menus, which we'll see in a moment. But if you want to do some background reading, it's there. So here we are back at the Structured Advanced Query page. Let's take a quick look at the 4 steps involved in building a query. First, we have the query construction component, component 1 here. This is where we're going to say what database we're querying and what we're looking for in it. And right now it's set to a very simple thing where we're looking in E. coli for compounds, but we can add conditions. So we can keep building on this, which I'm going to show you in a little bit with some of our examples. Now, you'll notice something interesting right away, which is that we actually have the number of instances of the thing you're looking at in the database you're looking at listed here. So this just tells you off the top what pool you're looking in. There are about 1,600 instances of compounds in our E. coli K12 database that we're currently set to. And that's useful knowledge. If you're going ahead and setting up one of these queries and you have a subcategory and it tells you you have 0 instances, you're already done, and you can go back and figure out a different query that may give you what you want. You may notice something else. While I have the mouse over compounds here, look up in the left corner. There's a tooltip up and out of the way where it won't disrupt your work that tells you what that class is. It's the class description. So in this case we see that compounds is a class that describes small molecules, that is non-macromolecular chemical compounds, and it talks a little bit about what the subclasses might be. And you can get that kind of mouse over when you go over different things, like we went down here to the query output and we got another tooltip about what the heck chemical formula is. And that brings us to part 2 of making the query, which is choosing your output. You choose the query, but we don't define the exact output for you. And based on the kind of objects you're querying against in the database, there's all sorts of things that you can churn out as the output. You know, you may want to run a query for proteins, but you may want the output to be calculated molecular weights, or the names plus the molecular weights, or many other things. If you're searching for something where you're going to get a list of object A, your output can be any combination of the traits that object A can have. So keep that in mind. Then down at 3 we have our select query output format. The default setting here is HTML, where it makes a nice little table for you. But you also have the option of tab delimited text, which of course can be useful for exporting, importing, transferring to an Excel file, using in some other way. Then at the bottom we have the submit query and reset query button. And you're going to do this forth. You're going to submit the query and find out what you want to do. So that's the basic structure of the page. Pretty straightforward, right? Enter your query, choose your output, select a format, submit. Let's try a couple of examples. For our first example, we're going to do something straightforward, and that's generate a list of genes in E. coli that contain TRP in their name. You know, where we might be suspicious that they have something to do with tryptophan, or that someone thought they did anyway. We want the output to contain the gene names and the gene product names. Okay, so let's select our database. When we click on this, we get a drop-down menu that has all the databases that are available in Biopsych right now. We're going to stick with K12. Then we need to select what we're searching in. Right now it's set to compounds, but we actually want to search the class of genes. And you'll see something interesting right away, which is genes is part of polymer segments. And we look up and say, okay, a polymer is, you know, DNA or an amino acid chain. Okay, it's pretty global. Then we have things called all genes, genes, phantom genes, pseudogenes, cryptic genes, interrupted genes. I'm not going to spend the time to mouse over each one right now, but going into them will explain what's going on with each category. For now, let's go over all genes, which encompasses all the things below it. And you can actually see how the indentation increases to show where things are in the hierarchy. But I'll pick all genes. And you may notice something if you're watching very carefully. When I changed to all genes, the query output changed around a little bit because we have different outputs available if we're looking at genes instead of looking at compounds in the database. And once again, you can see that we have 4,585 instances of the type of thing we're looking at. In this case, the stuff that's in the all genes category. Pretty straightforward. Down here in the output specification, we have name. That's going to be these gene names. And we have product. And fortunately, that's what we were interested in anyway, so we'll leave it there. We can add columns, which I'll get into a little bit later. From here, I'm going to bounce back up and actually make the query that we want to make. Right now, if I were to just click submit, I would get a list of all genes and all their products. Interesting. And notice that we actually have fewer products available than we have names, of course, because we chose all genes, which includes things like pseudogenes that we don't think make a product, and so there's no product frame in the database. Now, to add a qualifier to the search, we go up here and click Add a Condition. And this gives us options. The default option is to do something involving the name, so we're good. We had many other options, some that might seem a little esoteric just at a glance until you get used to them. You can search with all sorts of things. And then we have this qualifier here. Fortunately, it's on the one we want also, contains the substring, but we could require it to be exactly something. We could require case sensitivity. We could require that there be no value. I don't think we'd get any results there. Our genes all have names. We can require all sorts of things. So we'll keep that. And we'll go here and type TRP. Okay, so here's our search. We're looking at an E. coli among all genes for names that contain TRP. We're going to output a list of names and the associated product names when available. It's going to be formatted in HTML as a table, and we're good to go. So let's submit. So here we are. This is our output. And before we even talk about the output, I want to point something out to you. Up at the top, here is what your query is in BioVelo. As I mentioned, if you want to learn about how to use the free-form query, well, there you go. This is what your structured query turned into in the underlying query language. So it's nice because you can actually put together structured queries, see what they get converted into, and then use that as a platform on which to learn more about structuring your own queries. And you can actually click on this and it'll take you through to the free-form advanced query page where you can edit the query manually yourself. So here is our query results. We have a single table of 10 rows, which in this case means 10 different genes that have TRP in the name, A, B, C, D, E, H, L, P, R, sorry, no P, H, L, R, S, T. And what's neat about this is we already get to see things like, okay, we have some metabolic genes, we have a leader peptide, we have a random conserved protein, that might be interesting to look at, we have TRPR, which needs a better name, we have a tRNA synthetase, and we have a tRNA. Nice, huh? Now, the other nice thing, of course, is that you can click through on any one of these. So if you're thinking, wow, what is TRPR? I can click through on this and it'll actually take me to the appropriate point in the underlying database, where we get to find out, oh, of course, it's this transcriptional repressor. Good to know. Now, you may have noticed, while all this was happening, that our search results, and of course our subsequent clickage through the database, all got generated in a second window. In my case, I have my browser set to tab out second windows. This is super handy since it means you can just keep launching things from the original window. So I'll close this now. So once again, we chose our database, we chose what we were looking for, we added a condition, in this case a name that contained some letters. We chose our output, name and product, decided to sort by the name, we chose our format, HTML, and we hit submit. And that's the basic search mechanism. So, before we move on and look at another couple examples, just show you a couple other cool things. These little triangles have a purpose. I can sort the list. And even though I chose name as the initial sort, I can resort by product name, ascending and descending. And this is going to be true for any column in your list. Okay, so let's take another look at another query now. This one is going to be a little bit more complicated. It's going to use a repeat operator. So for this one, let's say that we want to ask about reactions, and we want to look for reactions that are catalyzed by isozymes, by more than one enzyme across the universe of available enzymes. And so let's first start by choosing Metapsych, our big aggregator of metabolic knowledge. That'll be our database. And as just an interesting random note here, my choosing Metapsych in the Structured Advanced Query page has not changed my underlying database for all of the top toolbar searches in Biopsych in general. So keep that in mind. If I am in the middle of the search and I think, oh, this could be done as a quick search, and flip up here, you need to change that organism if it's not the one that you wanted it to be. Okay, so let's go down here. We're looking in Metapsych for, click away from that, and down. Reactions. There are 7,930 instances of reactions in Metapsych. Let's go with small molecule reactions. That's reactions in which all the participants are small molecules. That tooltip on the upper left tells me that. 7,100 of those, give or take. Click on that. And you notice how the page keeps changing every time I change what I'm looking at. Again, this is because it knows what's available to us. The underlying searchable and deliverable items keep changing. Now, we already have one condition slot open because the query page we didn't reset it between our last query and this one, so it's still set to think that we want to have a condition on this query. We don't just want to return all the small molecule reactions. Let's select an attribute here. Click on that and go for enzymatic reaction. There are 3,883 of these. Now, one thing I should mention here is just seeing these numbers as you go along gives you useful information. Metapsych has 7,100 small molecule reactions, but only 3,900 enzymatic reactions, meaning that a pretty solid 3,100 or so, 3,200 or so of those small molecule reactions in Metapsych currently aren't linked to an enzyme. Now clearly we're trying to catch up with this, and some of those are actually going to be hypothetical reactions from incompletely known pathways. Some of them are going to be spontaneous reactions, but just keep in mind as these numbers come up that you're receiving information about what's in the database. This is knowledge right here. You suddenly know, okay, I'm actually looking at slightly more than half of the total reactions. That's good to know. So that when I see my final results, I won't be shocked. Okay, let's pick that. Okay, now we have where for some object in enzymatic reactions, da-da-da. Now, this is assuming, so this has reset and added this thing here because it's assuming that we're actually going to want to look at something about enzymatic reactions. Now, what did we get here? Why did we get here? Well, before we were looking in genes and we had picked name, which is a trait of genes. Here we're looking at small molecule reactions and we're asking it to explore something about an associated frame type, enzymatic reactions. That's interesting. In this case, we actually don't want it to do that, but that's the default where it said, okay, for enzymatic reaction, X is happening. And what we really want to ask is about the number of enzymatic reactions. So we click the number of objects. And again, it restructures. And you'll quickly get used to this dynamic restructuring of the search page in response to what you're doing. And so now what we're starting to ask is, in Metapsych, how many small molecule reactions are there where the number of enzymatic reactions associated with them is something? We could ask for cases where there's just the one. What I was actually interested in is asking for cases where there's more than one. So instead of equal to, we're going to say greater than, and we're going to say 1. Okay, our query is set. We're looking in Metapsych for small molecule reactions where the number of enzymatic reactions is greater than 1. Good enough. Now down below, the first column is still name. This is going to be the name of the reaction. The second column right now is set to balance state, which has to do with the elemental balance of the reaction. It's great that we have this knowledge. It's not what we're caring about right now in this query. So we want to find out something else. And what we might actually want to have as an output is enzymatic reactions. That enzymatic reaction name. And we might want to add additional outputs. We might want to add a column here, which I get by clicking on adding a column. And if we regret adding that column, we can always click on this little X And notice the tooltip, if you look up to the upper left again, the tooltip is telling you now that clicking on this will remove the column. So I'll do that. And now I go over add a column, and I'll add that back because I really did want it. So what are our options here? We can look at citations, we can look at other things. We have this in pathway one, and this specifies pathways that a reaction occurs in. Now that's interesting. So let's say we want to look at that. So now what's our query? We're looking in Metapsych across all small molecule reactions, all 7,100 of them, where the number of objects of enzymatic reactions for which we only have 3,800 values is greater than 1. When we get that list of small molecule reactions that fit that requirement, we're asking the structured advanced query to give us names, enzymatic reactions, and pathways that those reactions are in. We're keeping it with the HTML sortable table, which is pretty much what you want to do if you're looking at stuff online. Tab delimited is by and large useful for when you want to export a bunch of results and you're going to do something yourself with them later. And let's submit. And here we are. Results. Once again, we have the BioVelo underlying structure of the search up here at the top. You can click through to edit that. Our query gave us 1,449 rows. The rows are centered on the reactions that we were asking about. So what this tells us is, of the reactions in Metapsych that have associated enzymatic reactions, 1,449 of them have more than one associated enzymatic reaction. That is to say, there are different isozymes, possibly across different organisms since we're in a multi-organism database, catalyzing these same reactions. So for example, our very first reaction on the list is 2-chloromuconolactone, that's hard to say, transforming to 2-chlorocis-cis-muconate. We have chloromuconate cycloisomerase and 2-chloromuconate cycloisomerase carrying that out. So same enzyme, probably in different organisms. And that reaction is not in a pathway. Then we can look down the list a little bit and see we have isomenthone plus NADPH to isomenthol plus NADP. And that's carried out by menthol dehydrogenase and neomenthol dehydrogenase. And both of those are part of menthol biosynthesis. Neat. And of course, this list is sortable, just like the other lists are sortable. So if I click this arrow, I have resorted my list. I could click through and sort by enzymatic reaction. I could also sort through and click by the in-pathway note. And this is nice because I've now grouped things by pathway, and I can say, oh, trichlorobenzene degradation, or I should really say 1,2,4 trichlorobenzene degradation, because who knows how the other trichlorobenzenes are degraded. Anyway, 1,2,4 trichlorobenzene degradation has some different isomers that go into it. So as a reminder, let's go back to the query. We queried in Metapsych across all the small molecule reactions, asking for cases where the number of objects of the enzymatic reaction slot were greater than 1. It returned to us that list of small molecule reactions by name, because we preferred that, along with the associated enzymatic reaction names and their status in pathways. And that gave us this table. Okay, pretty straightforward. So let's go back to the Structured Advanced Query page. So here we are back at the Structured Advanced Query page, back on E. coli, and now we're going to try a third query that will use embedded repeat operators. Now for this one, we're going to try to find metabolic pathways in E. coli having more than 3 reactions, and where none of the reactions has the reactant acetaldehyde in it. Maybe we're prejudiced, or maybe we're trying to figure out an interesting metabolic engineering problem, perhaps for a piece of software we have to try and solve, and we need a pathway that's long enough for the software to operate on, but we also know we don't want to monkey around with acetaldehyde pathways for whatever reasons. Perhaps for the purposes of our assay we just can't. Okay, so we don't even want to have to probe around manually and find this. We want a list. Okay, well, our query database, we'll stick with E. coli, but remember we could always pick something else. We want to look up some pathways. We have 290 pathways in this E. coli database right now. Nice. We need to add a condition here. We don't really care about the name right now. We actually care about the reaction list. Now each pathway has a reaction list slot, so we have 290 values to look at. Now we're not looking at some specific trait contained within reaction lists, though we could look at specific names here. You could actually dredge up pathways that involve specific reactions in this way, for example. Instead, we just care about how many items are in the reaction list. So we're going to go up here and we're going to select the operator, the number of objects of, should seem familiar, and we're going to go with greater than, again, and 3. Okay. Now that's part of our query, but we need to add the rest. Because remember, we didn't just want pathways with more than 3 reactions. We also wanted to rule out a certain substrate. Let's go to add a condition. This lets us add atomic conditions, which is to say the conditions aren't particularly contingent on each other. They're just sort of different filters where you'll get some intersection or union of them depending on how you add them. So let's go with and. You can see we have the or not, and not, and there's a description above telling you what these Boolean operators mean. Remember, tooltips up and on the left. Always just look up there if you're not sure what's happening and you're over something. We'll go with and. Okay, now we went with and by default it gave us the name again. The default assumption is you're going to look at names. We're not trying to guide you to look at names, we just had to pick a default and that was it. Okay, so how do we want to ask the question about whether or not acetaldehyde is present? Well, here's one way to do it. Let's grab reaction list again. Now note what this means. This means that we're looking at reaction list 2 different times, and we're requiring that our query against reaction list be true both times. We're requiring that the reaction list have more than 3 values, and we're requiring now something else about the reaction list. So you can query the same trait, the same slot in a frame over and over again to finagle out the data that you want. So let's pick an operator here. It's going to be for no objects, and we're going to select an attribute here of reaction list. So let's go down the list here and we pick substrates. And we have name, substring, here we go, acetaldehyde. Okay, maybe a little confusing. Let me explain all that, starting from the top. We're looking in E. coli K12 for pathways for which 2 different queries are both true. The first one is that the number of objects in the reaction list slot is more than 3. This pathway, to make it through our search here, has to have more than 3 reactions in it. The second is that none of the objects in the reaction list can have a substrate with the name containing acetaldehyde. Okay, so you can see you kind of need to slow down and stare at these every so often, but it makes a lot of sense once you think about what you're asking. And in this case, it may look like a big gamish of stuff, but you're really just asking 2 very straightforward queries against, in this case, the same trait on pathways and requiring that they both meet certain rules. And so this is going to tell us if a pathway has more than 3 reactions and none of those reactions name acetaldehyde as substrates, then we're good. They pass, they'll be on our answer list. So what kind of answer list do we want? Let's go down and take a look. The default here is to give us the pathway name and to give us the reaction list. And really we could do all sorts of things here. Since this was a very theoretical example, it's hard to say what we're actually interested in. Are we interested in the in-pathway trait? Are we interested in, you kind of have to look through and see what these things refer to. Are we interested in taxonomic range? Are we interested in things that contain hypothetical reactions? Now that's interesting. Only 6 of these contain hypotheticals. Let's go with that. So we're going to see names and hypothetical reactions if they're present. So one more time, right before we hit submit, we're looking in E. coli K12 for pathways where 2 things are true. 1, the number of objects in the reaction list is more than 3. And 2, that no objects in the reaction list have substrates with the name containing acetaldehyde. Okay? Let's submit. And here we are, search results. 109 rows. So in E. coli, as represented in our E. coli database, there are 109 pathways that both contain more than 3 reactions and do not do anything at all with acetaldehyde, or acetaldehyde derivatives that would have that in the name. Pretty straightforward, right? Nice. And in our output here we have additional information. 6 of those pathways contained hypothetical reactions, and we could actually sort by those hypothetical reactions, of course. There we go. Now if we were about to embark on some computational biology thing where we tried to predict enzymes to carry out these hypothetical reactions, would be in a good place. And this is kind of nice. So you can do queries, you can specifically filter down to the subsets of things you want to look at. You can stack multiple searches on each other. And one of the great things about this is, say this gave you 109 pathways like it did, and you thought, well shoot, I thought that would give me 30 pathways. I for sure thought I was filtering down to a smaller group. This is more than I want to look at. Well, you go back to the query page and you can just add traits. Maybe you want to change something around, make it more than 4. Maybe you want to rule out another substrate. Maybe you want to do something else entirely. You can keep adding conditions. And you notice this is kind of nested. We can add conditions here also. Instead of adding a whole extra search about substrates, we could just add another substrate condition here to say, no objects where substrates are acetaldehyde or something else. We could go with an or, add another name, add a substring, add, who knows, glucose. I don't know if this will actually do anything. And we could run that query again. In fact, let's try running that query again. And here we are. We ran the query again, 98 rows. So we cut out 11 pathways by ruling out glucose as a substrate. And you can see you can keep layering searches on here. You can focus down on what you're trying to find. And I'm kind of a junkie for searches like that, where you can focus in and get specific things. It's very useful once you get going with it. And just out of curiosity, let's sort by hypothetical reactions again. And we can see we didn't lose any of our hypothetical reactions when we ruled out glucose. If I had a better memory, I would know that already based on what's here, but I wasn't really paying attention. This is one of the nice things. You can just go through, keep layering on queries, and you'll notice, if you just take a quick look up here, our results keep getting tabbed out here. So we don't have to lose one set of query results to get another, and we can go back and forth between them and compare. Okay, so now we've been focusing on these searches that add additional operators, that look around a lot, that let us keep stacking query requirements to focus down, but one of the very powerful features of the structured advanced query is the ability to look at more than one database. So let's take a look at that now. So here we are back one last time in this webinar on the Structured Advanced Query page, and we're going to take a look at how you query across multiple databases. Now, this is the kind of query that requires the most playing around and tinkering to really figure out how to do what you want. But it also has a lot of value because it means that you can take a set of results from one database and feed them into another. So say, for example, that we had started out looking in Metapsych for proteins, where the name contained the word methyl citrate. Let's say that was our query. Let's just kill the second column here. Let's submit that. Okay, so here are our results from that pretty simple look. We have 7 proteins in Metapsych that mention methyl citrate in the name. 3 synthases, 3 dehydratases, 1 lyase. Good to know. But what if we were curious about how many of those are from EcoPsych and we don't really feel like clicking through on each one and seeing if it's present in E. coli? Well, we can do something about that. Going back to this same query page that we had before, let's add an additional operation. Let's add a search component. So we can leave our original query alone the way it was, and we click on this thing and click combine each previous result with the following results. Now what this means is the results from this search, instead of being fed out to you automatically, will be fed into another search where we pick another database if we want. So let's pick E. coli K12 and we look for something. So in this case we're going to look in E. coli K12 for, again, proteins. And we need to go over here, add a condition. Now before I do this, notice something here. Now that we've added a second query, we have variable names here, Z1, Z2. What this means is the output of this query gets called Z1, and the output of this query gets called Z2. This matters for displaying the results, but it also matters, as you'll see in a moment, for feeding queries into following queries. So let's add a condition here. Let's say that we're going to look in E. coli K12 for proteins where the name of these proteins, and these are Z2, remember, is equal to what? Well, let's switch to variable entry, and now we can have it be equal to the name of Z1. Makes sense, right? So let's look for proteins where this is true in Metapsych, and let's take that subset and look for proteins in E. coli where the name of the E. coli protein matches the name of the Metapsych protein. Nice, right? Then we can go down to the bottom here and we can say, well, let me see the Z2s, the E. coli proteins, in this column here, and let me see the Z1 names in the right side column, and we'll sort by the left. Okay, quick refresher, reminder. What are we looking at here? We are querying Metapsych for proteins where the name contains the substring methyl citrate. That was our initial query. We're feeding those results into another query. In the next query, we take E. coli K12 and we query it for proteins where the name of those proteins is equal to the names of those Z1 proteins, the output of the first query. Query feeds into query and out to the result. Let's submit. And here we are in our results. From our initial 7 that the first query gave us from Metapsych, we're down to 4 that are present in EcoPsych as well. And of course this means there are 3 of those in Metapsych that are not present in EcoPsych. Interesting, right? And this is a super basic example of how you can go back and forth and shove data between databases. But it's a really handy feature. It's something that the advanced query page here gives you, and you can actually keep stacking stuff up through multiple databases. This is open-ended. It'll be a little slower each time you do that. It'll take longer because it's going through each database, but it does mean that you can ask queries about the intersection of many databases. You could potentially, if you felt like it, go across about 4 different databases and see what their intersection of, say, a certain kind of metabolic reaction is. This is all possible using the Structured Advanced Query page. With that in mind, we're going to go back to the default Structured Advanced Query page one more time and just make sure we have a good understanding of what's going on. So let's do that. Okay, so one more time, the Structured Advanced Query page, you get to it from the search menu under Advanced. Up at the top, you can switch to the Freeform Advanced Query page if you're feeling adventurous. We have the Advanced Query documentation. You do a 4-step process where you design your query up here in our expanding query design area, where you can add conditions and add additional search components and search across multiple databases. Then you select your output, and you can add columns and remove columns and build up the kind of output you want, which will generate a sorted table or sortable table, or a tab delimited file, which you'll pick down here when you select Query Output, and down in 4 you'll submit a query. And as always, if you have an issue, you can click on the Report Errors or Provide Feedback button. Let us know, if you have something you're trying to query and it's not working out. Maybe there's a bug, maybe it's something about how the database is put together that you're not familiar with yet, and we can help you out. We're excited about helping people out with designing queries, figuring out how to get what they need out of the Biosite collection of databases. So hopefully this has given you a good stepping stone to go from an intermediate user to an advanced user, to really play with the Structured Advanced Query page, and maybe even to branch out into the free-form BioVelo query. Thanks for watching, and I hope you'll come back for our next webinar.